All right, so in 12.2, we're going to be looking at angles and angle measure. And we were talking in the last video about how your calculator has two different modes, one for degrees and one for radians. You guys know all about degrees by now. We're going to be learning about a new angle measurement called radians. So first we're going to learn about angles in standard position, which comes first, and then we will learn about these new angle measurements called radians. So an angle in standard position, I'm going to draw a little picture here, kind of highlight. So this is just your standard coordinate system, you know, the XY axis. So angles in standard position start right here. The center of the angle is in the middle. We call that the vertex. I will label that in just a second. We label this part of the x-axis, the right-hand side of the x-axis, we call that the initial side. Alright, so this measurement is called the initial side of an angle, and then the angle opens up counterclockwise and then lands somewhere, anywhere around the coordinate system, and wherever that angle lands, so we're opening around this way, wherever that angle lands, we call that the terminal side. Alright, so they're basically two rays that end inside at 0, 0, and we call that point in the center the vertex. And then it opens up counterclockwise, and that side where it ends is called the terminal side. Okay, so we're going to look at two quick examples. We're going to draw them in standard position. So 80 degrees would look something like this. We all know what 90 degrees looks like. That's a right angle. So this right here is always our initial side. The angle opens right from the origin, and then 80 degrees would be just shy of 90 degrees, so maybe something like that. Alright, so the angle opens counterclockwise, like that, and that measurement is an 80-degree angle. So that is in standard position. Now for part B with a negative angle, things are a little bit different. Instead of opening counterclockwise, they go clockwise. So a negative angle goes in reverse order of what they typically go in. So we still have the coordinate system. We've still got the same initial side right here. However, our angle is going to open backward in this direction. So negative 90 would take us from here back to here. So negative 105 is going to take us 15 degrees more in this direction. So about 15 degrees would be maybe that far. So that's our terminal side, but like I said, since we're going in a negative direction, opens backward like that. And so we call that a negative 105 degrees. Positive 105 degrees would open this way to about the same spot right here. Okay, so just two examples like that. The next thing that you will see are things that go around more than once. So let's flip to the next page. Example 2, we're drawing an angle in standard position that measures 600 degrees. Okay, so we know we're going around at least once. So here's what happens. We start here, same initial side, same vertex that our angle is opening from. So we go around at least once. We know that for sure. So we start here, go around at least once. That's 360 degrees. So now let's do some quick side math. So 600 degrees minus 360 degrees. We want to see how much is still left to go. So if we do 600 minus 360, what we get is 240 degrees. So I've made it around once. I still have to go 240 degrees. So here's 90. Here's 180. Okay, so let's see if I go 180 more. Let's see how far I still have to go. You could always do this little work in a calculator too. So 240 minus 180, I still have 60 degrees to go. So I'm going to go 60 more degrees, which lands me right about there. Alright, so that would be your terminal side. So my angle went around once, around another half, and then 60 more degrees. That's a total of 600. We had like 360, 180 more, and then 60 more, and it lands right there. So it lands in the same spot as 240 degrees would be in. And that's something that we call coterminal angles. If the terminal side would be in the exact same spot, even though we technically have two different names for that angle, that would be a coterminal angle. So let me give you the exact definition. We are looking at two or more angles in standard position. Okay, two or more angles in standard position, meaning initial side here, vertex here, with the same terminal side. Okay, so the example that we were just talking about from example 2, 600 degrees and 240 degrees would be coterminal angles because they would have their terminal side in the exact same spot. We also could give a bunch of different names to that angle. If we went around a whole extra loop and landed right there again, so we could, from here, we could go up 360 more degrees, like go around all over again, and that would be 960 degrees. We could also go from here and go backwards, like we did with -105. So we could go backwards 90 degrees, and then this would be backward another 30, because we were 60 from this point, which means we're 30 from this point. So if we go back 90 and another 30, that would be -120. Really, there are an infinite number of names that you could give to that angle. So a little trick is wherever you are, you either add or subtract 360 degrees. Oops, sorry, that's a little crammed. So you either add or subtract 360 degrees. So here I subtracted 360 to get from here to here. I actually technically subtracted 360 again to get from here to here. From here I added 360 to get here. So it's basically just going around 360 again and landing in the same spot. So you could either be going backward or forward. So example 3, we're going to take that and we're going to come up with two other coterminal angles for each one of these angles here. So 15 degrees is just a little bit off of the initial side right here. So all I'm going to do with this is I'm going to take the angle that you're given, I'm going to add 360 degrees, and then subtract 360 degrees. So 15 degrees, if I go all the way around the circle again in a counterclockwise direction, I will land at 375. So that means if I wanted to measure out 375 degrees, it would be at the exact same spot as the 15-degree angle would. Or if I started at 15 degrees and wanted to go backward around the circle, another full rotation, it would land me at -345. So any of these three angles here would actually land me at the exact same spot on the circle. Same thing with part B. If I start at -45 degrees, which is 45 degrees back, so right in the middle here, I could add 360 degrees if I wanted to go around once more in the normal direction, the counterclockwise direction, and that would be 315 degrees. So that would be like going around 315 degrees and landing right there, same exact spot. Or I could go backward another revolution, and that would land me at -405 degrees. So for the example 3s that you'll see in your homework, these are pretty straightforward. You just take your angle, you add 360 to get the positive measure, then you subtract 360 to get the negative measure. But like I said, there are an infinite number. So I could keep adding 360 to this, I could keep subtracting 360 from this, and I would just keep coming up with more coterminal angles. Okay, so that's the first section, all about measuring out these angles in standard position. The next half of the lesson is going to teach us about these new measurements called radians. And so the original definition that I'm going to write down here is going to seem very wordy, pretty confusing, but we will walk you through this and you will be just fine. So a radian is all based on arc length, all right? So draw this out. So here's a circle that is sitting centered right at the origin. And we have, our initial side, and then we're going to draw in coterminal side somewhere around here. So you've got your angle right in the middle. Okay, so that is the picture that we're going to use while we're comparing what a radian is. Okay, so the book has this super technical, long definition that I think would pretty much only confuse you. The basis is I want you guys to remember something about circumference. So this, if you go all the way around the circle, the circumference would be 2 pi r, right? So normally you go all the way around the circle, the circumference would be 2 pi r, okay? So what if we start talking about something called the unit circle, and the unit circle is something with a radius of 1. So if the radius was 1, then the circumference would be 2 pi. So if you went all the way around the unit circle, the circumference would be 2 pi. Okay? So 1 complete revolution would be 2 pi radians. So it's a measure of arc length. And arc length would be like whatever measurement this is here. This measurement right there would be your arc length. So like I said, if you went all the way around, the arc length would be the circumference, which if my radius was 1 would be 2 pi radians. So 1 complete revolution is equal to 2 pi radians. However, we know that 1 complete revolution is equal to 360 degrees. So what that means is that 2 pi radians is equal to 360 degrees. I'm sure you guys did unit conversion in chemistry or something where you converted centimeters to inches or, liters to gallons, things like that. So this is one of those things. We've got 2 different ways to measure angles, and so we can learn to convert back and forth between them. So if 2 pi radians is equal to 360 degrees, let's set this up. If I wanted to know what 1 radian was equal to, I would divide both sides by 2 pi. So this tells me that 1 radian is equal to, and then I can reduce this down by 2, 180 degrees divided by pi. Okay, seems very confusing until we actually start working with it. Or if I wanted to go the other way, this right here, if I wanted to get 1 degree, I would divide this by 360 degrees. Same thing over here. And that means that 1 degree is equal to, reduce this by 2, pi over 180 radians. So that's what we call the conversion factor. We're going to use that to go back and forth. So from degrees to radians and vice versa. I'm going to set you guys up a nice little visual aid here. So if I give you a measurement in degrees and you want to put it into radians, what you do is you multiply by pi over 180. And that's what we have right here. 1 degree is equal to pi over 180 radians. So to go from degrees into radians, you multiply by pi over 180. To go from radians into degrees, you do the exact opposite. You multiply by this number, 180 over pi. Okay, so that's your conversion factor. Radians are going to feel very, very weird because I literally just introduced them to you about 2.5 minutes ago. So it's going to take us some practice to figure out exactly how to use them and exactly what they mean. Okay, so this example, number 4, we are going to practice converting back and forth between them. So 120 degrees, I'm in degrees, I want to get to radians, so I'm going to multiply by pi over 180. Okay, so you multiply by pi over 180. And then the next step that you'll typically take is to reduce them down. So 120 over 180, they're both multiples of 60. So I'm going to reduce down by 60. That leaves me with 2 here and 3 here. So what that reduces down to is 2 pi over 3. So my measurement of 120 degrees is the same as 2 pi over 3 radians, which basically means, so here, if I go all the way around, that's 2 pi. If I go halfway around, that's pi. So I'm going 2/3 of the way to this point right here. That's what this tells me. Okay, next one, negative 3 pi over 8. I'm in radians. I want to convert to degrees, so I multiply by 180 over pi. And then exact same thing as I did with part A. Anything you can reduce down, you're going to do that. So notice these pi's are going to cancel, which is what gets me into something that looks more like degrees. And then 180 and 8, they are both divisible by 4. So if I divide this by 4, I'm left with 2. If I divide this by 4, I'm left with 45. Okay, so let's multiply out here. So negative 3 times 45, that is negative 135 degrees. And then all I had left in the denominator was 2. So negative 135 divided by 2 is negative 65.5 degrees. So that is going backward, remember, measuring in a clockwise direction rather than a counterclockwise direction. All right, so the next thing we're going to do is on the back of this page, we're going to write down all the degree measurements and all the radian measurements. So I'm going to run around. I'm hoping the degrees are familiar. It's like this spot right here, this is 0 degrees. Haven't started yet, haven't moved at all. Now let's fill in the big ones that we know. So 90 degrees, 180 degrees, 270 degrees, and then when we end, this is 360 degrees. So it's 0 and it's also 360. That makes those coterminal angles. Then we start going in 45s. So halfway between 0 and 90, that's 45 degrees. Go 45 degrees more right here, and I'm at 135. Then 180, 45 degrees more, puts me at 225 right here. Then 270. Up 45 again, and this is 315, and then I finish my circle at 360. And then these ones are by 30 degrees, so 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and again, we end at 360. So those you should know. That's from geometry. I'm not going to spend a ton of time going over that. We should recognize angle measures like that when we see them. Okay? But the new thing that we are looking at today is we are talking about something called radians. So this is 0 radians. Okay? And I said on the front, if you go all the way around, that's the same as 2 pi radians. So this is also 2 pi. That's like not starting yet versus already completing a full revolution. So if this is 2 pi, only going halfway around would be pi. Okay, now let's start filling in some other things. Halfway between 0 and pi would be half of pi. So this right here, we call it pi over 2. It's pi, but then cut in half. So this is 0. This is half of pi. This is pi. This is 2 pi. So this would be 1.5. Remember, 1.5 is the same as 3 halves. So this is 3 halves times pi. That's what that measurement is right here. Let's see if I can zoom this out a little so I can leave it all. There we go. Okay, so those are the main ones. Let's start doing the 45 degrees now. We're going to do a little conversion over on the side here. 45 degrees, if I want to convert it to radians, I multiply by pi over 180. And 45 and 180 are both multiples of 45. So I'm left with the 1 here, and then I'm left with a 4 here. So that is pi over 4. Okay, so this measurement right here is pi over 4. So this is 1 pi over 4, this is 2 pi over 4. And we know that 2 over 4 reduces down to 1/2. This would be 3 pi over 4. This is 4 pi over 4, so I'm just going around in the same measurement, and 4 pi over 4 is just pi. This is 5 pi over 4. This is 6 pi over 4, and 6 over 4 reduces down to 3 halves. This is 7 pi over 4. And then this is 8 pi over 4, and 8 over 4 is 2. Alright, so that is the pi over 4, and now let's go around by 30. So convert, again, I'll do it over here. So 30 degrees, if we convert that into radians, 30 and 180 are both multiples of 30. So this reduces down to 1. 180 divided by 30 is 6. So that is pi over 6. So instead of going up by 30 degrees every time, we're going to go up by pi over 6. So this first one is pi over 6, aka 1 pi over 6. And this is 2 pi over 6. And 2 pi over 6, 2 over 6 reduces down to 1/3. So this is 1/3 of pi, or pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 3 over 6 is 1/2. 4 pi over 6, 4 over 6 is 2/3. 5 pi over 6. This is 6 pi over 6, which is 1. 7 pi over 6. 8 pi over 6. 8 over 6 is 4/3. 9 pi over 6. 9 over 6 is 3 halves. 10 pi over 6. 10 over 6 is 5/3, and 11 pi over 6. Well, I guess finally 12 pi over 6, and 12 over 6 is 2. So those are all your radian measures. At this point, you're basically just using these in your notes to kind of reference back and get all of those measurements. We're going to work with them more over the next couple days, and eventually they will make more sense, and eventually you will even have them memorized, I promise. All right, last little thing we're going to talk about, arc length, which I mentioned a little bit in the front. A central angle, we've already been using central angles. This is an angle with a vertex at the center. Okay, so let me draw you a little picture over here. So here's a circle. If I go right here, that's the center of the circle. So any angle that starts right there and has its vertex right at that point. All right, so let's make an angle this way. So this is a little angle. So that right there, this is an example of a central angle. Okay, and then last little definition. So an arc length. An arc length is like this measurement right here. And it's not a straight line, so we can't use a distance formula or anything like that. But what we end up doing is we've got this nice little formula for it. All right, so arc length, we've always considered it S for some reason. You never know. It is the product of the radius and the central angle in radians. Okay, so I'm going to write that in words. Product of the radius and the central angle in radians. Okay, so that part is super, super, super important, that the angle is measured in radians. If it's not measured in radians, then it won't give us the arc length. And the radian measurement itself comes from the arc length, okay, which we kind of have on the front there. Last example for this set of notes. A circle has a diameter of 9 centimeters. Okay, so the diameter is 9 centimeters. Find the arc length if the central angle is 60 degrees. All right, so our angle is 60 degrees. However, if we look back at this definition, we need the radius. So remember, the diameter is twice the radius. So if the diameter is 9, the radius would be half of that, which is 4.5 centimeters. Okay, and then our central angle is supposed to be in radians. So if the measurement is 60 degrees, let's go up to our circle. 60 degrees is the same as pi over 3 radians. Okay, so now that we've got everything we need, we're going to plug it into the arc length formula. So it's the radius times the central angle in radians. So that's 4.5 and then times pi over 3. All right, so that would be something that you could just plug right into your calculator, and I don't have one with me currently, but I know that when you do, you get approximately 4.7. We're going to round to the nearest tenth, and then this would be in centimeters. Make sure you keep the same unit that they give you right there. Okay, so that would be your answer. All right, so as we continue, we will do more with these radian measures, but this is kind of an introduction for you.